Physical properties.
Soil density. Density represents weight per unit volume of a substance. This is how you measure soil density. Materials. Weighing scale, water, soil samples, and graduated cylinder. This is a picture where we can see all the materials used to make this project. Procedure. Weigh 100 grams of soil sample on the balance. Then add water into the graduated cylinder until it reaches 100 milliliters and fill the cylinder with the soil sample. The volume of the sample of water will go up, so the soil will increase. Now you have to fill the table. Soil texture, using a sieve. Soil texture is an important indicator of the ability of soil to absorb and hold water and plant nutrients. This method consists of making a profile test using a soil sieve to separate out the different particles by their size. Materials. Weighing scale, weighing paper, soil samples, they must be dry, paper and soil sieves. Here we can also see all the materials used to make this project. Procedure. Arrange the soil sieves to set the largest size on the top. Then set 100 grams of the sample onto the paper and weigh the soil sample after breaking it in small particles. Now put the sample in the first sieve and shake it over the second one. Repeat it with every sieve. Collect the remaining sample in every sieve and determine its mass in the balance, and finally calculate the relative percentage of sand, silt and clay. Here we can see the remaining sample in every sieve. Finally, the soil sample is clay soil. And here we can see it.
Soil permeability. Permeability is a measurement of how easily liquid flows through a material or soil. Materials. Soil sample, radiate cylinder, funnel, ring stand, beaker, and timer. Procedure. First, fill a beaker with soil sample until the mark of 100 milliliters. Then, put the soil sample in the funnel, place it in the ring stand. Pour 100 milliliters of water in the funnel and then percolate water will come out from the funnel and it will fall on the beaker. Start recording as soon as the first drop of percolated water comes out from the funnel. Stop timing when the water reaches the mark of 50 milliliters and repeat this step with every soil sample and compare how many seconds it takes from the water to reach the mark. This is a picture of a classmate making the project. And this is a picture of the timer and the soil sample. This is the permeability table.
Porosity. Porosity is how much water a substance can hold. It starts as a percentage of the material's total volume. Pore space is the amount of empty space in a rock or other its substance. Materials. Soil samples, water, beaker, graduate cylinder, and spoon. Here we can see classmates working in the lab. Procedure. Fill a beaker with the first soil sample until the line of 100 milliliters. Secondly, fill a graduate cylinder with water until the line of 100 milliliters. Then, using the graduate cylinder, slowly and carefully pour water into the beaker until the level reaches the top of your soil sample. Then, subtract the volume of water remaining in the graduate cylinder from the total volume, 100 milliliters. This is the pore space volume, or the amount of water you added to your sample. And finally, to determine the porosity of the sample, divide the pore space volume by the total volume and multiply the result by 100. This is the table of porosity.
Soil texture. Texture refers to the size of particles that make up the soil. The terms sand, silt, and clay refer to relative size of the soil particles. Sand, being the large size of the particles, feels gritty. Silt, being moderate in size, has smooth or fluory texture. Clay, being the smaller size of particles, feels sticky. The materials are soil sample, jar, this is detergent, teaspoon, and water. This is a picture of the materials. Procedure. First, spread soil on a newspaper to dry them. Remove all rocks, trash, roots, grassland, and clouds. Finally, pulverize the soil with fill a tall, slender jar. Then add a teaspoon of non-foaming disguises detergent and put on a thick fitting lid and shake hard for 10 to 15 minutes. This shaking breaks a part of soil aggregates and separates the soil into individual mineral particles. Set the jar where it will not be disturbed for 2 to 3 days. Soil particles will settle out according to size. After 1 minute, mark on the jar the depth of the sand. After 2 hours, mark on the jar the depth of the silt, and when the water clears, mark off the jar the clay level. This typically takes 1 to 3 days, but some soils may take weeks. And this is a picture of the soil samples. And there are the results. This is a photo with the jar and the soil.
To sum up,